Hi everybody, my name is Mohammad Sajid Akhtar and I'm going to present a briefing about my project, which is control of single phase inverter using C2000 microcontroller. Let us begin. We know nowadays everybody is talking about the renewable energy. Why? The reason is very straight, because the renewable energy is nowadays is a boom due to the less and very less carbon footprint. And among those renewable energy, we know the PV generation is one of the highest demanded sources. We know that the solar PV generation has climbed up to 179 terawatt hour, in which is approximately 22%, and now it has already surpassed near about 1000 terawatt hour. We also know that after the wind energy, solar energy is the most demanded renewable energy. So we can go further and see what are the fundamentals of the PV generation. PV generation, the basic building block is the PV module, which needs to be after that, which needs to be converted in the AC, because the generation of the PV module is DC, and for the load or for the connecting to the grid, it needs to be converted in the AC with the help of inverter. So the fundamental interface of the PV system with single phase inverter is hereby details. As my project is based on the C2000 microcontroller, which is a microcontroller manufactured by the Texas Instrument. So just look up some fundamental of this controller. Actually, this is a onboard controller, which is very advanced level, and every block is already there in its board, like the PWM, which is the pulse width modulation chip, analog to digital converter, comparator module, and everything is there. So we can use this microcontroller for the PV panel very efficiently. The main advantage to use this controller is the high power efficiency and the less THD, that is the harmonic distortion. So the aim of this literature is to simulate the single stage converter. For this, a modeling has been done with the help of PI MPPT. As we know, the MPPT is the maximum power point tracking technique, which normally used to get the maximum power based on the several algorithm. And the next session of paper just introduced the Texas Instrument make C2000 microcontroller kit for the solar panel. Here the PV modules. Now we assume that we have to design a PV system to produce 100 kilowatt capacity, and let us assume the output voltage is 290 volt. According to the calculation, we need 10 numbers parallel module and 47 numbers of series module to produce desired power output. Here you can also see the voltage and current graph which may be obtained from this combination as a function of the irradiance of the PV module. Now we can go through one by one the different system block of the that means PV generation. The first basic block is the PV module I've already discussed, and the second one is the DC to DC boost converter with maximum power point tracking controller. Here you can see the PV array is given to a DC to D. The output of the PV array can be given to the DC to DC boost converter, which is a combination of capacitor, inductor, diode, and an IGBT, where the IGBT can be triggered by an external logic circuit which is known as MPPT controller, and their output is totally based on the algorithm. For this project, I have taken the algorithm which is known as the perturb and observe PO method to establish reference voltage. So what is the actually PNO MPPT controller? So here you can see a flow chart of the algorithm of this controller. In this perturb and observe method algorithm, the system sends the voltage and current as well as the current sample or the previous sample. Then it will calculate the current power and the previous power and accordingly calculate the difference of the current power and the previous power, which is also known as a DP. And depend upon the DP, it increase or decrease the voltage, which further generate a pulse for the DC that means DC to DC boost converter. Next action is the single phase inverter. As we know that for the load or to the connect with the grid, we need that DC to convert in the AC power, and for that inverter, single phase inverter here is by use. This inverter is a PWM inverter to just achieve the pure sinusoidal wave and after that one LC filter is used to just reduce the excessive harmonics up to the acceptable level. There are so many filter can be designed for this purpose, that is LCL filter, LC filter. Here we can taking only the LC filter due to its maximum harmonic reduction nature. So here is some calculation which depicts how we design the single phase inverter. These are some data, that is the input voltage is normally 420 volt, output voltage, output power, fundamental frequency, what may be the THD, all the things are given. And according to the calculation, we have designed the inductor used for the filter, then the capacitor, and after that because this single phase inverter, one PI controller is also used, so we have to also design the KP and KPI, which is that is proportionate and integral gain of that PI controller. Now after calculation, all the things has been implemented by the MATLAB simulation through Simulink. Here you can see a building block diagram of the MATLAB simulation, where this is a PV array, and the input of this PV array is normally feeding by a variable just to simulate the variation in the irradiance of the PV array. Here is a DC to DC boost converter, here is the inverter LC filter, and these are the controller. Here is the load. So Now we can go through the simulation result. Here you can see the PV voltage and current due to the variation in irradiance of the simulation. Here you can see the variation in the irradiance. It is vary up to 800 watt per square meter, and also the maximum up to 1000 watts per square meter. According to this variation, there is a variation in the PV voltage and PV current. Now, this is the output of the DC to DC boost converter, and due to that is the MPPT technique. You can see there is a width modulation. Clearly, it has been seen in this graph. So, according to the variation in the irradiance, which leads to the variation in the voltage, it's modulate the pulse width, and accordingly there will be variation into the voltage and the current, try to achieve the maximum power at that particular irradiance. Here is the output of the inverter. You can see that the output is purely sinusoidal, and it also gives the very less harmonic distortion due to the filter, LC filter, which has been used for the simulation. Now we can discuss some of the basic concept of the TI, that is the Texas Instrument makes C2000 solar microcontroller kit. This all things have already integrated in a single kit, which is very effective. And you can see there are the different module on this chip. Like this is DC to DC buck boost converter. This is the controller. This is the DC to DC boost MPPT, which we are using in our simulation. This is the inverter module. So we can see that every module is already on board in this microcontroller kit. And this is the basic block diagram of the microcontroller kit. From PV panel to this kit, then which is a DC to DC converter, then DC to AC inverter, and which is the AC output. And this all, that is this DC to DC converter, and the inverter is controlled by a Piccolo digital controller on chip controller. These are the sub block diagram and the electronic circuit, which is a power stage of this microcontroller inverter. These controller is consisting of the PWM analog to digital converter module, analog comparator module, and then the digital control module. So all things is going one by one, and the same thing which has already happened in our simulation, that can be done by the with the help of electronic circuits. This is a basic block diagram of the DC to DC converter stage of this electronic kit. And you can see there is a MPPT algorithm and the feedback control, where it's try to achieve the maximum power through this algorithm. So come across our conclusion. that this the TI-MAC, the 2000 microcontroller unit is very effective because it is already tested, simulated, and with the help of the LC filter we have and DC to DC boost converter, we have already compared that the output is very effective, that we the maximum power, we can get the maximum power, and also the harmonic free output. So from this I'm going to end this presentation. Thanks. If you have any question, you can approach me at mohammahsa@dortmund.ca. Thanks.